out the record. There we go. Let's try that. All right. Hey, gang. So welcome to DOM Calculator Review. Joe was gracious enough to donate some code for us to refactor. So let's take a look at it. All right. So first, let's see if it works. 1 plus 2 equals 3. Excellent. Times 9. All right, looking good so far, and it clears and everything. Awesome. Well done, Joe. So let's take a peek at the code. All right, so we're declaring some elements up here, coercing them into an array. That's an interesting approach to this. So the process that I go through when I'm looking through some code like this is on my first pass, as I'm looking through the code, I'm going to get rid of anything that that I just don't like for whatever reason. So
be ruthless, please.
I'm gonna. Careful what you wish for. So first thing, get element by ID, get elements by tag name, get elements by class name. Like I super don't like those methods anymore. So I'd way rather use query selector and query selector all for everything.
Why?
Because it's more consistent in the type that it returns. So with get elements by tag name, I always get a collection, even if I only want one. With IDs, I only get one, even if I want more than one, even though you should probably only have one with an ID. So with query selector and query selector all, I'm being a lot more explicit about how many of them that I want. And I have a little bit more control over that. Also, if I need to modify this down the road to be like, oh, screen is inside of a div or something like that, you can just change the selector. And there's no equivalent way to do that with the other ones. There's no like performance hit or anything like that. So I always do them like that. And this one is multiple. I can change that to query selector all. We're going to use semicolons. Let's stay consistent on it. Okay. So we've got these things up here. Next thing is I don't like the E for programmer abbrev. So let's write out the whole word because E could be all kinds of different things.
Kyle.
Yep.
Is there a functional reason why in the HTML the word span was used instead of just like button?
I don't know. We'll take a look. Yeah, because these are all spans. Oh, why did they do this instead of like using buttons on them?
Exactly.
Buttons would have made more sense. I don't know. I didn't make it. But no, a button is semantically way more accurate. Okay, so we can change that to event. And
The E up on line 7 or 8 now. Too late, missed.
Got it. There's one here, here. And we still got some more refactoring to do with that, but that's the first thing, like explodes out to me.
There's one other E.
Oh, that's it.
Yeah, there.
All right. And then we got this function. Okay. We got this function. Not bad. Very nice. Instead of parse int, I think this is one where I think the hack works a little bit better. Oh, and also is this string concatenation? No, this is actual addition. Cool. first operand join. All right, I'm gonna have to tear that one apart a little bit, but I don't like parse int, and I'll show you a hack that does the same thing in a sec. Ah, beautiful. Capturing the key codes too. So again, let's make that event and give the space around it. Get rid of the comment. In fact, I can probably, let's see, this is 85. So I'm going to say range 85 to plus 85 plus 24. Search for E dot and replace it with event dot globally.
Is that Vim stuff or is this stuff?
That was Vim stuff. Although I think I went too far. Hang on. All right. Oh, I see what happened there. I got it started like happening recursively. It was a shot. All right, event. Actually, strictly speaking, the thing I was just trying to do was a sed thing rather than a Vim thing. Sed is a command line tool for stream editor, but it's also in Vim. Okay.
2 lines up, there's another one. Between 47 and 58, yeah.
Beautiful. All right, so important questions that still work. Beautiful. All right, so we're still in business. So one more thing, I'll probably get rid of this code comment also. So reason why is like, yeah, that's what this does. And really, if you want to be more explicit, like you're adding like key support or something, then maybe have a function or something that that indicates that. But I don't think the comment actually adds any clarity to it. Okay, so actually, like very few like super goofy things in here. Oh, one more thing I want to do for sure is if we're going to use semicolons, let's stay consistent about semicolons. It's there, there. There, good, good, good. But like, I'm usually looking for things like that, variables that don't do anything, comments, things with like terrible names. And we're actually in pretty good shape here, so hats off to Joe. Get rid of that. Sometimes I'll look for weird, space, like white space issues, like there's too much white space or not enough white space around something. All right, so now
When it comes to semicolons, clearly I'm pretty bad with those. When do you use semicolons? When don't you?
all or none, like most of the time. So
in the case of all, is it after every closed parenthesis, after every closed curly bracket?
It's after every statement. So calling a function is a statement. So we would do it that way. This inside here is an expression. We don't put semicolons after expressions. So an expression is something that will evaluate to something. a statement is a command to the computer to execute something, like save something to a variable, or call this function, or something like that.
Does that
So
stem
semicolons go
from?
after statements.
Does that stem from out of curiosity? I used to do like MATLAB coding, and every time you wouldn't put a semicolon, it would print that to the console. Is that kind of where that stems from? Is that you're muting a console output, even though it automatically does that now?
No, it's actually a super interesting reason for it. So it's a statement terminator. Well, when a language is being compiled, like it doesn't understand what operate is or event.target. These are just like Roman characters, right? So it does this thing called lexing, where it breaks it up into little component pieces, and then works through each of them like as instructions. And it knows that something should be considered one command because while it's lexing it, it goes, oh, this semicolon is the end of the statement. So I just need to consider everything before that as like, I got to figure out how I execute that. So if you don't put them in JavaScript, your code still gets them. JavaScript does a thing called ASI, or automatic semicolon insertion, and it just adds them to your code for you. So for a long time, like 5 years, people stopped using semicolons because there are so few cases where not using semicolons would get you in trouble. There's like 2. And they're so rare that like you would just never do them anyway. So like, oh, you can make your code so much less noisy, so much easier to read if you leave off the semicolons. And then JavaScript started adding some new features recently that increase the surface area of like damage you can cause by not using semicolons. And so now everybody's using semicolons again. Welcome to Bleeding Edge, everybody. But yeah, I had just gotten used to not writing with semicolons, and now they're back. So there you have it. Okay, so my second pass through this, what I want to do is start extracting functions. So inlining these functions with fat arrows is exactly how I would write it the first time. And then once it's written, extract those functions out. So let's, for example, go down here. So this arrow function, add event listener key down. So what's happening in here? I call this like handle key down. Might get a better name for that later. We'll handle key down. And it takes in an event. And now we can just copy and paste all of this code into that. And yeah, there we go. And then this becomes handle key down. That pattern that I just did, I love that pattern. I think it's like, that's like the key to writing JavaScript like a pro. So ask me questions about that. The thing
Do you
that I
not
just
use
did.
parentheses after handle key down?
No, because add event listener takes 2 arguments. The first is the name of the event that you're responding to as a string. The second is a function definition. This is a function definition, this handle key down thing. If I invoke it, what's that?
Call.
Function call.
A function call. So that's going to evaluate to whatever the return value of the function is. In this case, the function isn't returning anything. And so I'm passing undefined. Undefined is not a function definition. So those are different things. But I can inline that like Joe has it, or had it up here. So that's an inlined function. This is the exact same thing extracted. More questions about what I just did?
Is it bad practice in JavaScript to have a function named as the same of some sort of variable? Or also, like, let's say I have a function, let's say I want to pass in arguments to a function. If I use that argument as the argument in the definition of the function, is that bad practice? Like, in other words, let's say I send inner text into a function that is specified with the default argument as inner text. Yeah, I don't know.
I don't think that works the way that you think it will. But there's a related thing. Hang on, Alice, no, it has never been a requirement in JS. We've had automatic semicolon insertion from the start. But like if I need to pass an argument into this handle key down thing, this is where this starts getting crazy. So what you would do, you still need to return, like add event listener needs a function definition as its second argument, period, the end. You could also get that by returning a function definition like this. And so now if I do that, I still haven't done anything different. This code is identical to what Joe originally wrote. But now I'm invoking it in that handler, and the thing that's being returned is a function definition. So what this lets us do, oops, sorry. That's the thing that's going to take the event. The thing that this lets us do is pass variables into that. So if I needed some external thing here, and now that inner function can see that. That's called a closure.
Mm-hmm.
So if you've been waiting to find out what a closure is, there you go.
Yeah.
All right, so we might talk about that more before the end of this. But all right, so I extracted the function. Neat. Did I successfully extract the function? Does this still work? Looks like it to me. Beautiful.
Can you test that with the keys?
Sure. Oop. Good call. Let's see what it's mad at me about. Oh, that's probably because I have Vimium on. Yeah. Oop. Ah, interesting. So it works with the number keys at the top of my keyboard, but it doesn't work with my 10 key.
Is that because they have different ASCII codes? Do they?
Yeah, almost definitely.
That makes sense.
Let's see, I can get the numbers to go, but I can't get the plus or equals to go. I got divide to work. All right, let's see if that worked before. Nope, didn't work on mine before either. That's not a problem. I'm not going to worry about it. All right, so I've extracted a function. Can also do that. Let's see, other functions I can extract. How's about this one? We got two of them here, actually. So we can make like a function handle button press. And make this handle button press. All right. And then we could even extract out this one right here too. We could make it something like attach event listener. Oops, and this needs to take in the event also. This is going to take in a button. And this is going to be attach event listener. Cool. Does it still work? Looks like it to me. Neat. Who can tell me what the value is in extracting those functions?
Maybe like if you wanted to expand the functionality of the calculator, you could use the same functions to handle different operators, for example, or different numbers, or like a dot, like a period or something like that.
Totally. If they're not inline, now I can reuse them. It's a good reason to do it. Why else?
I think in the case of the calculator, it's pretty clear what the button does, but in the case of a different application, it gives a name to the function, what the buttons are going to do, what that event listener is going to do.
Absolutely. It also makes this kind of read like a story now. For each button in the button array, attach an event listener. Okay, cool. And like handle button press is the most descriptive function name I've ever had, but it's helping our code read a little bit more literary. And also, here's another thing I like. Let's find that other extraction we did, this one. It kind of separates out, let's get rid of this.
What is the button array again?
Button array is all of the spans, or it's the array version of all of the spans.
Oh.
So another thing I like about this is, so everything below this is functions. That means all the application's actually doing when it starts is these. Those are the statements that it runs right off the bat. Everything else is just function definitions waiting to be called. Another thing I like about splitting out functions is now these are testable independently. So if I wanted to run them through a testing framework or something like that, I have that option, separate from how they're being consumed by, like, for example, the event listener. Neat. Also, I think it just reads easier. All right, questions?
What is the function of storing all those spans in an array instead of just accessing them where they are?
Well, so we need to, each of the buttons needs an event listener, right? So I need to get all those buttons so I can do that. Why not keep them in an array?
Could you set it up to where they don't each need an event listener, but the event listeners are equipped to handle different HTML elements?
You could, but that actually gets more brittle than what we have now. Because, like, let's say we have like a thing on here for scientific calculator, graphing calculator, like whatever else, right? We probably don't want to attach event listeners to every single one of these things individually. We want to consider our treatment of the buttons sort of together as one unit. Also, they didn't give us a ton of easy ways to do this. Like, how would I target the 7 as different from the 8? So really what I do is I loop through these and I figure out which ones are operators and which ones aren't and that kind of stuff. And the way that I would handle a 7 and an 8 and a 9 and a 4 and a 5 and a 6 is identical. So I can just write one function for that. Other questions?
Yeah, I have a question, Kyle.
Mm-hmm.
So in like the project requirements, the second bonus says to try to evaluate the expression without using eval. What is eval? I don't know what that is.
So
I didn't do it, but that wasn't trying to get the bonus. That was just not knowing what eval is.
Sure. So eval is, you can pass the eval function any string you want, and it'll run it as JavaScript. So, for example, if I do eval and then oops. Eval function high like that as a string. So that's just some string, right? Cool. Well, now I have a high function.
So you could store like functions basically in function, like you could store what you're going to call a function with in like, let's say a hash or something like that. I spent an hour trying to figure that out yesterday.
So the way that like most people solve this is like you read the stuff off of the screen and it's something like a string that says 1 + 2 × 5 or whatever. And if you eval that string, it'll evaluate it as math. The problem with eval, and the reason you see phrases like eval is evil, look at all this. When is eval not evil? Why is eval evil? The reason why is oftentimes you're dealing with something like user input. So you're reading this user input and then you want to evaluate it. Cool. Everybody familiar with Bobby tables? I love getting to explain programmer jokes to students. That's the Bobby tables joke. So if you just take random string inputs from users and run them as code, things like this happen. It's a bad idea, don't do it. But it is the easiest way to solve this, the DOM calculator.
Because you're basically saying then a user could input whatever code they want into your system.
Exactly. And you have said that you trust it, which is probably a bad idea.
That makes sense.
Cool, what else? All right, let's keep cranking. So other things that I want to do.
What about that switch statement?
Yeah, that's the ifs and elses and switches. Yeah, I don't like this. So this is another thing where like perfectly acceptable to write your code this way. Like I do that kind of thing all the time. But anytime you're writing a switch or an if, ask yourself real hard if you have to. Because a lot of the times you don't. And there's a particular pattern that I'm going to show you for getting around this that can clean this up a little bit. But first, let me tell you why. I gave a talk a little while back called Programming Without Ifs. And let's see. And the reason that ifs are a problem is a thing called cyclomatic complexity. Cyclomatic complexity is a super fancy $20 word for how many different paths are there through your code. So if we have something like an if statement, now there's two paths to your code. There is the one where the if statement matches and the one where the if statement doesn't. If you start nesting if statements, now you have exponentially more different paths through your code. And some things that cause cyclomatic complexity, all of those. Ternaries, if, else, switch case, try catch, Boolean operators, all of those are increase your cyclomatic complexity. So the problem with that is that those are more tests that you have to write because you want to test all the different paths through your code. Yowza. That's more different things that can break. Usually people don't make too many mistakes with it as they're writing it. It's when somebody else 3 weeks later comes along and needs to add a new case to your switch, and all of a sudden the order that the cases are in super matters for some reason, and now you're in trouble. They're also really hard to read. So a pattern that we can do to get rid of our switch statement here is, let's say we make an object called operations. And
hey, Kyle.
Yep.
I haven't done this lab yet, and I know a couple others maybe haven't either.
Mm-hmm.
So do you mind just like saying what we want this function to do really quick?
Absolutely.
Okay.
So,
thank you.
well, let's take a look at it. So this is check operator. And it's happening with whenever this operate function gets called. And that happens on key down and button press. So like if we hit equals, operate gets called. And what operate does is we go, okay, if there's nothing on the screen, or if the thing on the screen is 0, then it's 0. Otherwise, we want to set the inner text to whatever check operator is. And so this is going to switch over operator, which I think is something that was being set way up here. And it's saying, all right, well, whatever that is, are we adding? Are we subtracting? Are we multiplying? Are we whatever? So the result of that is going to come back as check operator and get sent to the screen. So, wow, that was kind of hard to follow, wasn't it? This is an example of spaghetti code. And so spaghetti code happens when you have things that are outside the function that you're changing and reading and relying on, and you need to trace it back through a bunch of functions. That's a very naturally occurring thing when you're working with a lot of data that's outside of your function.
Is
So
that again best practice, or like how would you fix that?
So the way that you fix that is by passing stuff in. So if this thing relies on operator, you go, all right, where the fuck did operator come from? So we can fix that by passing it in. And we go, okay, so check operator is here. That means I need to pass it in here. All right, well, where does that come from? All right, well, what if we passed it in to this? All right. What about this? All right, well, we could pass it in to there. Where else? Operator. Cool. And so then, all right, how does button press get operator? And you go, all right, well, ooh, this isn't getting called by me. This is getting called by the event listener. This is where that closure trick comes in. So if we say handle button press actually takes in operator and then returns a function that's actually going to handle the event. Now that handle button press thing over here can take in operator. And you go, oh shit, well, I'm in like kind of the same position I was in before, where this thing is actually getting called by this like for each here. All right, well, how am I going to get the operator into that? Exact same thing. Operator And then that's going to return this function like that. All right, well, what about this attached event listener? Oh, hang on, baby. And now, check that shit out. Now they're right next to each other. Come here, baby. Yep, come here. Come here. Want to see my class? Oh, this is Miles. Say hi.
Hi.
All right. Mwah. So that's how we fix that spaghetti problem, is by passing that all the way down. But in situations where it gets a little bit tricky, like we're passing a function definition, so we can't like actually pass it in, we can use that closure trick to get around it. All right, so now that's getting past operator directly. So hum. How are we going to get rid of the switch? So I want, if the operator is something, then we have some function that comes back from that, right? So our trick for that is to make an object, and we're going to make those different cases. We're going to make those keys of the object. So I can take these and make those keys in the object. Okay. And then the thing that we want is these functions. So that one's going to be add. That one's going to be subtract. This one's going to be multiply.
So if you don't call the functions, you can put them right there and it won't run it.
Exactly.
Fuck.
Do we still need our one-on-one today, John?
I think so.
Yeah, we want the definition of it. We don't want to actually invoke it. We don't want the return value of it yet. We just want to be able to get the right function.
And you could also store that as an anonymous function if you wanted to, that does call, but that's not necessary.
So now I could say something like const function to call is operations at operator. And now I can return function to call and invoke it. Does the same thing. And we can clean this up a little bit also. We could say, all right, anytime I'm just saving something in a variable and then like immediately returning it, especially since I'm also like invoking it here, well, wouldn't that be the same as doing that? And oh, that made that a lot simpler. Pretty fucking wild. Questions about that? That one's heavy.
Yeah, can you just give another quick overview of closure?
Yeah.
Maybe just even in like a simple example broken out from this project.
I'm loving it. So, all right. I have a function called outer. And it returns a function called inner. So closure, if I have some variable up here, and I do something with it here. Say I'm logging it or something. Some variable didn't get passed into outer. How on earth did it see it? It sees it through closure. A closure is when an inner scope references an outer scope. That's it. That's all there is to it. You do it all the time. Like, you can't not do it. All right. Some variables defined in this global scope, and we're using it inside of the scope of this function, so it's accessing it through closure. Neat. If we put that inside of this function, that would also be accessing it through closure, because you're referencing this outer scope here. Now, where this gets cool is if that gets actually passed in there like that. So now this inner function can see the stuff that was passed into the outer function, but it's not out in the global scope. It's not like loosey-goosey wild. It's still contained. It's tight and disciplined, but it's getting it from another function's scope. Let's use a metaphor. So let's see if I have a bag or something handy. Okay, so this is an envelope. These are some baby pictures of me. And this box of beer is a container of some kind. It's a box. All right, so if I put my baby picture folder into the box of beer, all right, I've got some kind of outer structure and some kind of inner structure. If I take these pictures and put them in the folder, I actually am putting them in the box and then in the folder. That's exactly what's happening with this outer and inner thing. I put some variable in the outer function, but the inner function can still use it, accessing it through closure. If I'm using some variable, so on this line, some variable is being accessed because it's an argument that was passed into the function. On this line, some variable is being accessed through closure. Here's where this gets powerful.
Wait, so on the inside, just to clarify, that some variable on line 4 is actually reading it from line 9, not from line 7.
No, it's reading it from the one that I'm on. So another way to do this would just be to say, I just put hi there.
Okay.
Now, where this gets wild is I can save that. I can say, because when I invoke outer with hi, the thing that returns back is a function definition. It's that inner function definition. So if I save that in a value, now I can call, holy shit, this is just the inner function. And it still has hi. It can still see that, because it remembers that from its outer scope.
Hey, Kyle.
Yep.
if between 6 and 7, if you set some variable to like buy, would line 7 update, or does it just have in what you put into it at the time of the return statement?
That's a good question. It depends on whether or not it's a simple type or a complex type. Complex types are objects, including every kind of object. So objects, arrays, functions, promises, those will update. Strings, Booleans, basically anything else, numbers, those will be whatever they were when it was defined.
Okay, thank you.
Or rather, whenever this one right here, whenever that was executed.
What were those two data types called again?
Simple types and complex types. Some of those are called primitive types and reference types. Now let's take a look at how we did this in this actual exercise. So on this one, attach event listener is outer. This function right here is inner. I'm using operator, even though it was actually passed into the outer function. So when I call event listener here and pass operator into it, immediately, oops, I should have returned that. Immediately, I get back this function definition, which is good. That's what I need. Except it can remember that operator used to be in its scope.
It's like the functional equivalent of this stuff in Ruby, like blocks with yields and stuff like that.
Correct.
Okay.
Blocks and yields and stuff are Ruby's like kind of like tip of the hat to functional programming. In the same way that JavaScript has OOP, but not really. Ruby has some functional things, but kind of not really. Closest you get is blocks and yields.
Do people use those blocks and yields a lot, or is that I probably would be better off focusing on functional programming in JavaScript and object-oriented programming in Ruby?
Those were two different questions, but I would say if you want to learn more about functional programming, Ruby is the dumbest way to do that. But if you fall in love with functional programming and you want to do some of that in Ruby, they make some affordances for you.
Okay, thank you.
Yep, no problem. As far as like whether or not whether you should learn OOP or FP, totally different question. If you don't want to go work down in the DTC, they don't do any functional programming down there. If you want to do a lot of like performance sensitive data transformations, like welcome to Club Functional. We'll probably be doing more functional stuff for the rest of the program than OOP stuff, just because React leans heavily on a lot of functional ideas, including this one. Also, one other thing, if this syntax was throwing you off, these two things are the exact same thing. Dope.
Can you possibly upload like your refactored version of the DOM calculator just so we can give it a look and
Maybe
pick apart a lot of that stuff?
Yeah, there's some other ones too. I'll post this one somewhere, and then I'll also I'll send you a link to ones that have been like all the way through and have like mega refactored. I think there's some version of this. It didn't handle all the corner cases, but I got it down to like 9 lines of code or something like that. Like something ridiculously, like offensively short. Cool. Other questions?
Maybe if you send both, we could compare, I guess, or something.
There you go. I like it, Katie. More questions about that closure idea. If that's the only idea that you take out of this like review, like that's heavy. It's super intellectual. It's probably the most intellectually rough thing that we do in the entire program. as closures. But if you grok that, then there's a lot about JavaScript that will kind of fall into place for you. And it comes in really handy in the React stuff in Mod 4.
Can you make up a closure problem? Asking a lot of questions here. If somebody else had a question, they could go first.
I have more closure examples on a blog post I wrote about them. And this isn't the last time where we're going to talk about closures, like if your head is hurting right now. But that's a good one. What else?
Maybe a future lesson, but we can talk about like function hoisting as well. I figure that that's similar in some sense.
Oh yeah, it's we can talk about that right now because it's easy. Function hoisting is, you know how all these functions are declared down at the bottom, except ultimately they all kind of get used at the top? That's function hoisting. So if I'm using the function, like this is called a function declaration. If I do it like this, I could rewrite this as that. That is called a function expression. So that's a function declaration. This is a function expression. So they work differently in that this attached event listener, that hoists. So I can declare it anywhere I want in the code. JavaScript does not give a shit. It will work from anywhere. This, like if I didn't have that, this code will break because I'm using attach event listener up here, but I declare it afterward. So I'd have to do that instead because it doesn't hoist.
So in general, is hoisting better?
That's a good question. I like hoisting a lot because this is really what the app does. I want to just start there. If I want to dig into how it does those things, I can follow the functions and stuff. Another reason that I like hoisting is that you have all these functions in here that call each other. I don't want to give a shit what order those happen in. Make sure that those functions are ordered correctly, and as soon as some function calls a function that it wasn't calling before, I need to redo the entire order. Like, what a stupid pain in the ass. It's like not adding any value. So I think function declarations and hoisting are like super good for that. About half of the JavaScript community like vehemently disagrees with me on this and thinks that hoisting is a problem because it's confusing. You use something and then you declare it. Whoa. And those people are mostly coming from other languages. Like hoisting is like an unusual idea. It's not, this isn't the only language that does it, but it's not common. And so if you're coming from a language that doesn't have something like this, then it seems weird and foreign and you don't like it. So there's a split in the JavaScript community. If somebody tells you that like, oh no, you can't do that because it hoists, that's kind of what they're talking about. But I love it and I'm not stopping, and you're gonna have to take it from my cold dead hands.
Kyle, do you have time to touch on real quick? You said you didn't like the parse int in the add subtract functions. Yeah, what would be an alternative to that?
Absolutely. So let's break this down a little bit. So okay, just trying to figure out what's happening here. So instead of parse int, so you do this when you have a string or a float and you're trying to make sure that it's read as a number. Another way you can do this is just with plus. You can call the parse int function and pass something into it, or you can just put plus in front of it. This is like quite literally a hack. I don't think that's how JavaScript is supposed to work, but it does, and I think it's way cleaner. Now, part of the thing that somebody might bark at you about on this, though, is your code is going to end up looking like that.
You need the joins on there too if you do the plus sign?
So I don't know what the joins are doing. What are the joins doing?
The joins, so the operands are being stored in an array. So the joins are joining those numbers together so that they're not added. Yeah.
So like, yeah, it's kind of hacky. You have the two pluses right next to each other. So you got that kind of thing going on. But if we compare that line and like the similar thing that's happening in subtract or multiply or divide, I think that's easier to read. And then there was one more thing that I was going to show you, and then I want to review real quick. So let's see, this is for the key down. Where's the buttons one? Here we go. So we're using event.target a ton in here. And it's adding a lot of noise to this, and especially event.target.innerText is getting used a lot. So I think that's a perfectly acceptable reason to just make that a separate variable. So we could call this, and I'm going to say content. I kind of don't like that. Why not? I'll start there. Event.target.innerText. Okay, cool. Watch what this does to the readability of this code.
It's funny, I noticed that problem with operator class, which I declared right above that, and I didn't realize I could also do that with the event target text.
Yes. On this one, we used inner HTML, but I think in this case, that's the same. Wow, we got rid of a lot of noise on that. Compared to that, a lot cleaner. Neat. So some things that I want you to take out of this. This plus to coerce something into a number. Coercing a string into a number is something you're going to have to do all the time in JavaScript. So having that one in your back pocket, that'll save you some heartache. I want you to remember extracting functions. Every time you're doing an inline event listener, like I write them inline at first too, but at some point, extract them out. It'll do wonders for the readability of your code. Another thing, this pattern here, which is called dictionary lookup, we can store functions on an object like this and then look them up with like the braces. Same way we would any other like value on an object. And you can basically replace any switch statement with this pattern. And to finish up that cyclomatic complexity shit, cyclomatic complexity of this, 1. Only one path through the code. Because we're saying that like all 4 of these are functionally equivalent because we're using them all in the exact same way. So the only path through the code is through that statement right there. Because really what we've done is turn logic into data. Anytime you can turn logic into data, your code gets simpler. And then we talked about closures. Having a function that returns a function and remembers what its scope was like, that's a closure. Cool. Some last questions before we break. So don't be disheartened if like the closure shit isn't clicking right away or the dictionary lookup stuff. These are fairly advanced JavaScript patterns, but like you're ready for them. So like we can start scratching at that. We'll talk about them a lot more next week also. Shoot, hopefully this was helpful. I'll upload this code and some other versions of this lesson I've done. I always base it on student code. And so if you look at some of the other videos, like the starting place is always different. So we always end up taking away some different things, but it's got a similar sort of format if you want to check out other DOM calculators. All right, thank you very much. Have a good lunch.
Thanks.
Thanks, Kyle.
Yep,
Let's
yep.
go.